Hello, everyone. This is Michelle, a product manager at Canonical for some data solutions. And together with me is Andrea, our AI PM, and Ichlal, our platform security product manager. Hello, Andrea. Hi, Ichlal. Can you tell us more about this webinar session that we will be jointly speaking about?
Yeah, absolutely. From my perspective, I've been working with the product engineering teams at Canonical for a couple of years now on getting our infrastructure ready to support confidential workloads. We have a large offering of confidential VMs available for public and private cloud deployments. And what a better way to highlight the security added value of this offering than to build on top of it a workload that a lot of people care about, namely with other canonical products. So that's why with Andreas, Kubeflow, and Michelle with OpenSearch, we are going to explore together today a confidential RAG offering.
It's super exciting. Andrea, on your side, you've been working a lot with AI and all, and probably confidential computing is something very interesting for you.
Indeed, and the more that the AI landscape evolves, and the more the Gen AI landscape evolves, the more there's a need for more security, and that's where I think confidential computing and enabling cloud-native applications to run on confidential computing environments or confidential workloads is going to become more pressuring. So, I think this webinar is going to be just the surface of a long journey on how ML actually needs confidential computing, and how they're gonna work together at scale in production to enable organizations that use highly sensitive data to scale their projects.
I'm really, really looking forward. So, yes, the topic is Gen AI security with confidential computing, highlighting few use cases such as RAG or LLM. And of course, the best way is to start that and how together with Andrea and Ichlal. So, the content will be the use case itself. We're going to talk about different data and AI security and confidentiality challenges, introduction to the confidential computing, and then what does confidential RAG looks like. Afterwards, we're going to wrap up with some best practices and, of course, conclusion. Let's start with some introduction or some Gen AI use cases, and Andrea will give a bit of an overview.
Sure. I mean, I often feel that everyone talks about Gen AI and there is a lot of hype around it. But what's the value that it brings is something that often people wonder. And looking around at the industry, it was interesting for me to see that on one hand, almost or more than half of the organizations want to adopt Gen AI. But it's not just because it's nice or because people talk about it, but it's also because it actually saves time, helps businesses, and the chatbots and the time that chatbots actually help enterprises save, which is more than 2 hours, is just one data point. But we can also look at the content generation piece, which Gen AI is clearly very good with. And then last but not least, the results. Rolling projects, ML projects in production it's an iterative process that once organizations manage to do that, it's easy to see how Gartner reported that 50, almost 16% actually report cost savings, which is an important data point to actually highlight that it's not just a hype, it's actually a new business or a new industry, as Jensen defined it at GTC this year, that is going to help organizations and also challenge leaders to think a bit differently on how they do all sorts of different tasks. Now, if you look at one of the use cases, I think we all have been talking to chatbots, and in financial services, is just one other example. As a banker, you want to use a chatbot for operational use cases, but if I think of the financial services industry, security is a key point. You have access to a lot of private data, a lot of sensitive data, and you don't want as an employee of the organization to compromise the confidentiality of the company or of the client. So how do you actually build such a chatbot? I think throughout today's sessions, we're gonna depict this situation and learn how to build it such that we can um, help our audience get better at it. Of course, any or most of the chatbots use RAG these days, or Retrieval-Augmented Generation. But what is RAG, Michelle? I know you've been an expert in RAG.
Yeah, it's a very interesting project. We were working with the team, but to keep it simple as a user of a chatbot, for example, you just want uh, a relevant outcome for whatever questions you throw in your chatbot, right? You also want it to be accurate. You also want it to be fast. You also want it to be useful in various contexts of inputs that you've added. So RAG is just an enabler of that. It's just a technology that optimizes the output of large language models in a way that the retrieval of data and augmentation of data makes sense in a way that the output or response, whatever you query or the user queried, has a very strong correct context. So imagine that you will just need to load gigantic data sets from multiple sources. You use a base LLM to be able to understand and train. You have a vector database that actually optimizes the retrieval and augmentation of the data that you are trying to get an outcome of. All of that processes is within that RAG. The good news with RAG is that it has implemented some processes where you don't need to continuously retrain the model of your machine learning in comparison to the traditional way of doing LLMs. In this way, it becomes more cost effective of improving LLM output. So, in a nutshell, that is RAG. And later, we're going to show a couple of blueprints. And if we deep dive into the technology components, if you really wanted to make sure that you use RAG and an advanced Gen AI solution design, you have to consider a lot of technology component from your chatbot application, the whole retrieval and ranking with a vector database, a model embedding, LLM, inference, guardrail, model repository, many components of it. And these are the things that we have to think about security practices, which we will deep dive later today as well. So, yeah, I think RAG is an interesting technology. However, it's fairly simple as a use case, let's say, for the users who wanted to use it for a specific use case, such as chatbot. And
Yeah. Oh, sorry. Go ahead. I had a question, but I can wait for a bit.
now you can go on with your question.
Yeah, I mean, looking at the components and terminology, I was curious why organizations need a vector database for RAG.
I think the good thing with databases right now is that it actually evolved and improved in a way that it can process data not as usual as you have rows and columns of data as metadata and all. Now it has a way to transform the data into a different formats such as vectors and also use neural network in understanding data and context within that database. And I think that's a good part of vector database because as I mentioned a while ago, nowadays, a database can also actually understand, retrieve, and augment context fast without, needing to retrain a machine learning model all the time. So yeah, I think that's the reason why it becomes very relevant to the whole LLM story. But I think Andrea, beyond that, RAG by itself um, has all these benefits, right? To improve customer experience, to boost employee productivity, and to accelerate process optimization, which is, if you think it in the context of the financial sector use case that we have talked a while ago, this is definitely some of the reasons why people will choose this way of creating this technology. However, Andrea, I'm very curious about the key considerations before you actually start creating your own LLMs or RAG system. Can you give us overview on that?
Of course, Michelle, and maybe a note. I don't think organizations and especially developers should train their LLMs. No, 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 don't do that. It's resource intensive. It takes time. Likely you don't have enough data. However, you can always use existing large language models and then fine tune them, learn them locally, and fine tune them. But beyond that, there are a couple of key considerations in general related to AI, and then furthermore with Gen AI on how much infrastructure you actually need. And start by utilizing the existing infrastructure and scale as the project matures, depending on your needs, depending on um, also what the capabilities are, what the timelines are. You can always, for example, start on a public cloud if there are no GPUs available in the existing infrastructure of the organization, and then move towards private cloud or hybrid cloud scenario as well. Also, iterate on your project. I think no machine learning project that I've worked on ever worked smoothly from the first trial. You'll often need to iterate, you need to experiment, you need to try different parameter combinations for tuning, hyperparameter tuning, and so on. And that's perfectly normal. Use tools to help you out, such as MLflow, to get easier visibility. But expect it as a journey where you have to try more than once. Also, look at the industry blueprint. If you think of RAG, it's a complex use case and it can easily be intimidating. So, looking at industry blueprints, looking at how um, how others approach such a problem is very easy. And then lowering the barrier entry with open source. I mean, everyone can think we are biased, right? Because we are in a we are working for an open source company. But on one hand, it requires initial lower investment. On the other hand, it accelerates innovation and it gives you access to the latest and greatest novelties in the market, and especially in the AI landscape. That's important because the speed of innovation is impressive. Um, Automate your workloads because having plenty of manual steps to run in order to do any activity related to machine learning, it becomes time consuming and also often it becomes too complicated. And on that front, we just had a webinar with Kim and us on how to automate ML workloads with Kubeflow pipeline. Feel free to look at that. And I intentionally left the security the last one, not because it's the least important, but rather because we're going to talk a lot about security today and build with security in mind, from securing the infrastructure that you're using to having user management, network isolation, and then going further to confidential computing when needed. I think is something very important. And I think I'm not sure if Visual agrees with me, but confidential computing is not always needed. Security is always needed. Confidential computing is suitable for some of the use cases, and maybe we can describe them throughout the webinar a bit more on when do we actually need that, why do we actually need confidential computing as well.
And there are different security issues in AI, ML, RAG, and all. And I'm very curious and wanted to have some conversations with you here, Andrea and Ijlal, because these three things are key things that we have to look at when we have some data AI project. So let's start with the security issue, which is evasion, which is doing the wrong things. Do you have any view on that, Ijlal, and share your views on AI or ML projects that it does this evasion issue?
Yeah, so AI deployments inherit all of the security vulnerabilities that can compromise any other non AI type of workloads. But on top of that, they bring new classes of security issues. So for evasion, I saw the other day a video capturing how a Tesla self driving system thought of a sun during a sunset as a red light. So that's an AI vulnerability that makes the system do the wrong thing. It is not necessarily malicious, but it's just an inherent vulnerability that comes with automating and relying on AI predictions for doing some actions. Poisoning, on the other hand, is having a malicious intent behind it. So there is usually an attacker who is determined to, for example, feed some sort of data that they now can force the AI to learn a type of behavior that can then lead to the wrong type of action. And then confidentiality. is important for all workloads, AI or not, but for AI specifically, there is more of a concern about losing the confidentiality of data and code. And the model itself is considered in many instances intellectual property. So now we are worried about basically a larger set of things that can be compromised and their confidentiality can be leaked. I think we can go into more details in the next slide. Uh, so what I've just described here is a need to protect code and data that we deem to be security sensitive and confidential. And this is not by any means a new requirement. I'm gonna lean here and invite everybody to think about a use case that all of us are familiar with. So SIM cards, um, we have them on our mobile phones. And I'm asking here the question, why do SIM cards exist? At the end of the day, they are just normal processing execution environments. They have some sort of processor, they have a ROM, they have RAM, they have IO, they run some sort of operating system. But when you look deeper into a SIM card, you realize that they are used, interestingly, by mobile network operators, MNOs, in order to execute what they think are security sensitive code and data within them. And this begs for me the following question. Why do network operators not just run these security sensitive workloads on the mobile phone's CPU? That's a more powerful CPU. Why do they have to go through the trouble of provisioning a new hardware that is resource constrained? I'm talking here about the SIM card, and then running their security workloads there. Yeah, so do they know something that we don't as application developers or as OS vendors? Next slide, please. Well, the answer for me is it turns out that they do not necessarily know a secret, but they have chosen to take action on the following fact of computing. Computing is, as an application developer, you are running at the least privileged layer. You are running in x86 parlance, you are running in ring 3. And underneath you, there is millions lines of code of what we call privileged system software. So this can be a host hypervisor, an operating system, the platform's firmware. And these are all pieces of software that you share the computing platform with, that you share the server with, you share the desktop with. And these are pieces of software that have been written by vendors that are not you, developers that you don't know who they are. And the reality is that all of this privileged system software, yes, it cannot necessarily, we're not saying that it is malicious, but it can be vulnerable. It will be. We know all of software is vulnerable. There are CVEs routinely that we do patch. So because you are running at the least privileged layer, and because the way computing has been done, it means that if there is a vulnerability in the OS kernel, then that OS kernel can then have the ability to compromise your application's code and data and leak it. What this means for you as an AI workload is if there is a 0-day vulnerability on the kernel or if that vulnerability is not patched yet by the platform owner, then potentially if it's exploited, you can and you should consider what it means for you that there is a risk that your model weights, that your training data and inference data can be leaked to malicious third parties or to competition. But we also live in a world where we have to acknowledge that some vendors, some software vendors, have malicious intents, and they can and they have been caught in instances where they have introduced backdoors. So the privileged software stack can be both malicious and vulnerable, and that's the worst case scenario. Next slide, please. So often when we discuss these vulnerabilities that are inherent to the way we do computing, as application developer, you accept that privileged system software can compromise you. We get the very understandable question of, well, I'm going to be a good citizen. I'm going to encrypt my data at rest. Maybe I'm going to use full disk encryption. I'm going to protect my keys. The next question that we hear as well is, Next slide. Yeah. Well, maybe I'm going to run in my VM or container a really hardened operating system. I'm going to pay my developers and incentivize them to adopt uh, um, a memory safe programming language, or maybe I'm going to put a lot of extra resources in doing thorough testing of my application. Our response is this is all good, and you should keep on doing that as an application developer, but it is not enough. Next slide, please. The reason it's not enough is all of those primitives, security primitives that we are used to, they aim to protect data and code when it is either at rest. So this is where full disk encryption comes in, for example, or they aim to protect data in transit. You are going hopefully to be using HTTPS, but they do nothing to address the data in use security gap. And when I say data in use, I simply mean the moment at which you want actually to derive some insight from your data. For example, you can keep your training data encrypted in a secondary memory, but then you actually need to do the training. So, what you need to do is to bring the data unencrypted in clear text from secondary memory into DRAM, into system memory. And during the entire time during which the processor is going to be computing, doing training or the inferencing, all of it, that is time in which data is sitting in clear text and able to be grabbed by any either malicious or vulnerable OS, firmware, and hypervisor. Let alone the fact that you can also be compromised by the host infrastructure human operators, administrators who have a lot of privileges, rightfully so, because they need to manage your VMs, for example, but those are risks that you have to consider. Next slide, please. So effectively, what we're saying is traditionally security has focused on protecting the host from the application, like protecting the OS from the application. But now with confidential computing, we're focusing on the opposite problem, which is I want to protect myself as an application from you as the host. Next slide, please. This requirement is very explicit, and I think you can easily understand the need of it when we think about running AI workloads in the public cloud, because that's an extreme case of you running in an environment that you know very little about and you have very little control over. The hardware is not yours. You have no say into what type of hypervisor is running. It is not you who controls the cadence at which you're going to do security patch and management, and you are not the ones who hires and vets the administrators who are going to be managing the infrastructure. So you can imagine if there is a vulnerability in the hypervisor or somebody tries to do a VM dump, maybe because they want to help you troubleshoot something. If your AI workload is in that VM, then effectively they will have access to your memory in clear text. And that's not something that you would want if you have proprietary security sensitive data. Now, this is a question that I like. I was like, okay, I understand the need for confidential computing in the public cloud, but I'm going to keep everything in my private data center. I'm going to deploy a robust private cloud. The response to that is, next slide, please. Private clouds and data centers, they do give you governance. And yes, this means that you will be the one deciding on which hardware to buy, whom you hire for managing the infrastructure, and what type of software stack you deploy. But private clouds do not give you security by default. The reason I'm making this statement is, next slide please, is the following. It's because the private cloud inherits many of the same vulnerabilities that the public cloud struggles with, in that you also have insiders who you rely on for managing the infrastructures. And those insiders can go rogue. You can do as much vetting and background checking, but those administrators, with the privileges that they have, they can decide to hand over data to whomever is pressuring them or to whomever they're working for other than you. But more realistically, we don't even have to be that extreme in our threat modeling. Very realistically, your hypervisor and your host OS, these are the same sort of pieces of software that the public cloud is running. And there, you know, and I know, everybody knows that there will be vulnerabilities disclosed and found within these pieces of software. And you know that because hopefully you have a patch management strategy for you to fix those vulnerabilities. But the thing is, there are zero-day vulnerabilities. Maybe the fix is going to come a bit later. Maybe you are not going to reboot the platform immediately to fix a vulnerability. And during all of that time, if you are running your AI workload in a non-confidential computing mode, then it means the vulnerability will be able again to leak your code and data. Next slide, please. And for many industries, for private clouds that we work with, such as telecom, they do have multi-tenancy requirements. Maybe there are internal parts of the organizations that do not necessarily trust each other because they deal with data of customers that do not want to trust each other. Or maybe you are offloading or trying to sell part of your private cloud infrastructure to somebody else. So in many ways, other than the governance requirements, which are stronger in a private cloud, confidential computing and better security, and the same security challenges that apply to the public cloud do apply to a private cloud deployment. So what is the solution? Are we advocating for just putting SIM cards for every application and distributing them to servers and desktops? Well, no, but kind of-ish, and I'm going to explain how is that. So SIM cards are physically isolated execution environments, but they are very resource constrained. Many years ago, we formulated as a security community the goal that we want to have isolation, but logically within the main CPU. This way we can have our cake and eat it too. We can still keep on using the powerful CPU resources, but still have a logical isolation from any other workload on which that is running on the same CPU. It took a lot of years for some truly innovative engineering work to happen at the silicon level. And the main primitive that makes confidential computing possible is a piece of hardware called the memory encryption engine that implements an AES encryption at the hardware level. And it is powerful enough for us to rely on it today in order to encrypt every memory within the DRAM and only decrypts it when it is brought back into the CPU. And this is very powerful. This is not full disk encryption for secondary memory. This is effectively DRAM encryption in real time. So if I go back to the example of somebody dumping your VM's memory, confidential computing does not stop this threat. I mean, they can still go and dump the memory, but what they will get out of it is encrypted text. So junk data, that makes no sense unless they can have access to the key, which they won't in a confidential computing environment because the key is protected in hardware within the CPU and the OS cannot read it. The hypervisor neither cannot read it. Next slide, please. Yeah, if we can move. Yeah, okay. So encryption at the DRAM level is used as a way to provide us isolation, but because this is confidential computing. We want the highest level of security. I cannot just ask a public cloud provider to turn on confidential computing and trust them that they will do so. I need to be able to cryptographically verify those claims of confidential computing, and that's what we refer to as attestation or remote attestation. And that's at a high level, what this means is that you're going to basically ask the confidential VM of your choice to give you a cryptographic token that reflects the state of the hardware underneath it and the state of the software that has been loaded within the confidential VM. For the latter, which is the software within the VM, it's reflected through accumulating a set of hashes that act as measurements. And you can refer or compare the measurements against a good expected measurement, and then you decide whether to release your AI model or your inference data to that CVM or not. Next slide, please. So this is a high-level attestation flow. Basically, the moment you should decide on when is it that you do this attestation protocol with the remote verifier, and the moment simply is when you are ready to release whatever you consider is secret. So if you consider the operating system to be secret, so the OS plus the AI model plus the data, then you should do attestation very early, maybe after the firmware has been loaded. But in most cases for AI deployments, what is considered confidential is really the application itself. So you would be fine and okay with, steps 1, 2, and 3. loading the entire VM all the way up until the guest OS. And then the guest OS, if you are choosing an Ubuntu confidential VM, will have an attestation agent. You request the verification from somebody else. You verify the verification token. If things are fine, then you release your AI model and your data. Next slide, please. The exciting part, is this theory or is this practice? Hardware has been shipping with confidential computing for x86 since some years now. So we have Intel SGX, which was a process level isolation, but the current generation is Intel TDX and AMD CVSMP, and the boundary for them is a VM. So whatever you were running in a non-confidential VM, you can just lift and shift it into a confidential VM. Other architectures are working on releasing hardware very soon. So we are going to see hardware from ARM-CCA for V9.2 architecture. RISC-V is also doing the same. And NVIDIA has been supporting a confidential mode for its GPUs since H100. So that's super important for AI because you cannot just rely on CPUs, especially for training. Next slide. This is building a cloud for confidential computing, especially a private cloud, can look daunting. And we acknowledged that a couple of years ago, which is when we started an effort at Canonical to offer a fully enlightened and enabled software stack for people to build confidential clouds with. So today for Intel TDX specifically, I'm linking here to the GitHub repository. We just offer Ubuntu optimized images which have the required kernels with the required patches for both host and guest. And we give you also user space for QEMU libvirt and firmware running within the VM, namely OVMF, an enabled form of OVMF. We just launched 2404 Intel TDX, and we're going to continue these efforts. At every Ubuntu release, we're going to have a Dash optimized TDX as well. If you just want something to start with, or if your deployment is just public cloud, or you want to get hands-on in the public cloud, then I'm very happy to announce that we do have the largest offering of confidential VM on all major public cloud providers. So you go to the likes of Azure Marketplace and you type Ubuntu confidential VM, you're gonna get starting with 2004 all of our images, and you just spin them and you have your confidential VM. It's as easy as that. Next slide, please. Of course, we acknowledge that AI workloads do need a GPU, so be mindful. In the next slide, I'm showing here the efforts we've been doing to make sure that the CPU works seamlessly with confidential GPUs. If you can move us, Michelle, to the next slide. Yes. So this is how a deployment specifically for the AI workload would look like. There is a confidential mode on an NVIDIA H100 GPU. You have the confidential VM running and a CPU with confidential computing. And we make sure that the attestation across both of them is unified and easy to consume. The traffic between CPU and GPU is encrypted and authenticated. And you are getting both. You are getting security and the computational benefits of running on a GPU. To be more concrete, I'm showing here NVIDIA's reference implementation. Very early on, they started working with Ubuntu as the OS on which they build their implementations for confidential AI. You see here a reference to our images running with kernels as early as 5.19. And in the next slide, please, I'm highlighting the next one more. Yeah. So this one, I'm highlighting the latest deployment guide from NVIDIA with the Intel TDX stack with Ubuntu and NVIDIA H100s. It's publicly available. If you have a hardware with Emerald Rapids, Intel Emerald Rapids, I highly recommend that you give this a shot and start, benefiting from the hardware capabilities that you've already paid for. A year ago, we launched a private preview for confidential AI on Azure. We were the first and only, actually, OS to support this. And just recently, we moved to GA for Azure with Azure as well.
Yeah, I was about to say that now that I think it's better for us, or it's clear for us and our audience what confidential computing comes with and how it can be used. The question or the elephant in the room is how do we use it for a RAG? And can it be used for a RAG if there's no GPU support yet? That's the second question. And I'll jump to the answer quickly. If it comes to RAG, specifically, you already have the LLMs. You don't need to do that much. And I think that's the beauty where confidential computing can really be used without having any constraints or that many constraints on the compute power resources as well. But before we get into that, let's look a bit at the RAG blueprint. Michelle.
Yeah, so this is the blueprint actually that was published by OPEA, or the Open Platform for Enterprise AI. It's a group of different people and organization that supports, the use of open source for any Gen AI solutions, and provide like an open ecosystem so that, through the use of open source, it delivers a secure, safe, scalable, and cost efficient solution in the Gen AI space. So this is the blueprint that we got from OPEA. Bear in mind that this is a blueprint that is actually not just covering, the whole RAG, but also a Gen AI reference solution. So from that specific blueprint, we kind of deep dive into what are those open source softwares that you can use to actually service different parts of RAG and advanced reference solutions for Gen AI. In this case, if you look at the whole architecture, of course, before you can, start making your own chatbot or AI chatbot, there should be some source of data. And these enterprise data can come from different databases, from different systems, or even from different toolings where you needed to subscribe of. You wanted to make sure that this data is properly loaded to your RAG systems. And that's the reason why, for example, you see there Kubeflow or OpenSearch can be good ingestion platform for those data. Then second is, of course, you have to have your UI, where that UI is technically your chatbot, and you can have different types of tooling such as LangChain or Streamlit. There are open source ones that you can use to set up your whole RAG system. The key considerations if you started creating your own RAG system is you have to consider different components, from the embedding model services that you needed to use, a vector database, a retrieval and ranking features that will kind of like get the data or retrieve the data and augment the data in a way that is relevant to whatever you ask your chatbot. And of course, the last part of the whole RAG is the whole, integration with an LLM. So that's where, Llama, GPT-4, and the rest can be used, and also a proper inferencing tools so that, your whole LLM setup can be faster and accurate. Other considerations for RAG are, guardrails and prompt processing. So, prompt processing, for example, can remember previous conversations within your RAG system. So, it's very important that you can it can remember the previous context that you have asked it. An optional part of RAG is, of course, the whole user feedback, where you kind of use toolings and open source tools that fine tune the machine learning models that you've chose, or the LLM that you've chose, and making sure that you have a proper model repository for that specific processes. So yes, this is the RAG system and the services that you needed to make, you know, to make it work. Some are optional, some are really, really necessary. And as you can see, open source tooling really do play a lot of role on making it work. This is not a standard. This is an example that Canonical showcase on how open source can be useful for different services. And of course, it depends on your use case to pick and choose the best services that you wanted to use, that is speaks to your needs. Let's go back again to Ichlal's point on data security and confidentiality. if you think about it in the use case of RAG, then you imagine, how do I make sure to secure and retain the data confidentiality of a RAG system? I think it's a very hard question to answer because it requires a lot of, architectural work, not just on the services itself, but to actually understand the motion of the data and machine learning models that goes around your RAG systems. And for instance, I can give you an example here, and you see those security logos. Is like, we have tried to deploy different open source tools in a confidential VM. So imagine using OpenSearch, for example, for the vector database, and it's deployed in a confidential VM, right? Running on an Intel TDX on an Ubuntu 2404 OS. Those are those work that you can actually do to make sure that even though you deploy it in a private cloud or public cloud, let's say, you have this assurance that once the data is actually in use, or even the model, let's say your chosen LLM models and the inference, you have chosen that the service, or like the service should run in an NVIDIA H100, because I think we would recommend GPU enable the inference and LLM. And in that way, those services are running in a confidential VM, right? And this gives this assurance that Ichlal has highlighted. Demo time, secure and confidential data and model of your LLM implementation is, of course, the goal. And this is a demo of a successful deployment of Charmed OpenSearch in a confidential VM deployed in Azure using Intel Trust Domain Extension Hardware Accelerator. So let's say that you have chosen Charmed OpenSearch to run complex RAG services such as Sentence Transformer, KNN, Neural Search, Guardrail. These functions can be deployed in Azure in different instances such as ECES v5 series or ECED SV5 series. So this demo showcases that the Charmed OpenSearch nodes is successfully deployed and running in a confidential VM, and quite straightforward. 3 OpenSearch nodes, OpenSearch dashboard, and the TLS. As you can see, we have been trying and testing, and it has been successfully deployed in this specific CVM. Failure is actually 0. It might be a straightforward deployment. However, we should ask about what is CVM and what does it contains, and what are the benefits of actually running Charmed OpenSearch there. So in a CVM, there's a hardware-based trusted execution environment, or TEE, that facilitates the deployment of trust domains, which are hardware isolated virtual machines designed to protect sensitive data and application from unauthorized access. So it might be quite simple to just deploy it in this specific instance in Azure REST Europe. However, you can see that the benefits are that no changes to application or programming model. It safeguards your vector database if you have chosen Charmed OpenSearch for the KNN neural network. It provides robust isolation, integrity, and confidentiality to your data or machine learning models that is running in a service that you've run in CVM. So this is the benefit, and it's quite very important, especially the security and confidentiality of your data. So Andrea, um, what do you think about the demo, the architecture, and the confidential computing discussions that we've done together with Ichlal?
I think both you and Jalal covered a lot of the infrastructure itself, but when it comes to such a use case, we need more than applications to run on top of an environment. And if I look bottom to top, first of all, we need hardware. And we already discussed about both on-prem as well as public cloud options. And then hardware automation provisioning tools as well. But then last but not least, we need an operating system such that we can then deploy the entire ecosystem on top. Uh, I would also like to add that we do need Kubernetes or container orchestration often as well for such use cases. And then also, whenever we're selecting our suite of tools or our infrastructure, we need to keep in mind the capabilities or the features, the enhancements that we need for our infrastructure. And they should not be isolated only for RAG, because very likely in your organization, you're going to do more than just a chatbot or RAG. You're going to have multiple machine learning use cases, and your infrastructure should feed them all. So on one hand, having vector databases, having the ability to fine tune models, to optimize models, to automate your workloads are just some of the capabilities that you need. And they are mostly related to the blueprint that you mentioned, but also they need to be adjusted, as I mentioned, because maybe if you do a lot of computer vision, there are different frameworks and libraries that you need to have rather than the ones used for video streaming or for sound generation. Now, trying to circle back to the confidential computing and the security itself, we need to keep security in mind at all layers of the stack, from the hardware itself all the way to the applications that are used, to the cloud native applications that are used to enable use cases such as RAG. Um, and that's an easy thing to do. We already discussed about them, but having an end-to-end stack that ensures the security and confidentiality of your data is something that is crucial, and it can easily help you accelerate um, the way you move your projects to production as well. Um, Now, looking a bit at the open source landscape, we already discussed about the hardware itself, but then you also a lot of the tools here have been already mentioned, so I'll not go into details. Also, being cognizant of time, but you also have to keep in mind that such an infrastructure, it never looks the same for two organizations. Not all organizations need pandas, PyTorch, and TensorFlow. Maybe they need something else, and that's important to adjust or to keep in mind on one hand, when you design your solution, but then also going back to the key considerations, evolve your infrastructure as your project matures. Don't design something extremely sophisticated at the beginning that might take way too long, that it might block actually the iteration on the machine learning projects themselves. Now, we are about to close it, so let's go a bit to some best practices related to security and confidential computing. So, Ishala, back to you.
All right. Yes, we have compiled, Andrea, Michelle, and I, the following best practices for an AI workload, particularly. So, the most important thing before thinking about what primitives, what solutions you need to deploy, you need to be very clear about what is your attacker model and what are you trying to protect yourself uh, against. And this brings us to also the need for you to define your assets, what it is that you're trying to protect. So with both these assets and attacker model, you can decide whether you want confidential computing if you deem the data to require that type of protection, whether you require the data to still reside on your private cloud, if it has some sovereignty requirements that it needs to meet, or whether it's fine to deploy it in a confidential VM in a public cloud. But starting with an attacker model and assets are a good foundation. And then as you move towards deciding on the primitives, definitely step into the journey that a piece of code or data takes. So when it is in secondary memory at rest, there are specific things you would want to deploy versus in transit versus at runtime, with confidential computing being the main system primitive for runtime security. But there are other cryptographic primitives that I would like to us to pay attention to as they continue maturing and making their way into mainstream security, like homomorphic encryption, like multi-party computation, perhaps um, zero knowledge proof. So all of these are useful alongside confidential computing for runtime security. And then to be more specific, it's not enough that you make sure that the development or the provision of your AI workload is secure. You need to make sure that the entire operations of it from day 0 until day 1000 is and beyond is secure. So you need a robust security patching management strategy. And then obviously continuous monitoring, continuous auditing of the access control rules that you've deployed is extremely important, and without overlooking the need to keep on educating the organization, meaning the humans who will be interacting either as end users or as administrators managing the infrastructure. There needs to be a plan to continue educating them on best practices as well. Um, that's all for what we wanted to share today. And I think, Michelle, you had some other things you wanted to call out.
Yes, Ijlal. Thank you for the best practices. I think for the RAG, we did focus on the discussion and the data in use, but of course, it's also very important to always think about in your data and AI infrastructure to think about it when your data is at rest, when your model is at rest, or when your data is in transit. So, thank you for those best practices, Ijlal, that you've shared and things that is beyond confidential computing too. For us, security is very important. It's a topic that we tackle at Canonical. We actually also offer an MLOps workshop, which is a 5-day workshop just focus on you know uh, guiding you on how to optimize your LLM in a way that we will teach you how to you know to build it, but at the same time to consult to for us to be a consultant of what are the best toolings that you can use. But at the same time, you will have a peer to discuss with what are your use cases and how those toolings and best practices can help you set it up. So it's a 5 days workshop that Canonical is offering, plus the security add-ons to your setup of, for example, a chatbot or any LLM or GenAI use cases. So feel free to scan the datasheet to get to know more information about it. But this mainly focuses a lot about RAG and building RAG. Other than that, would you like to share, Ijlal, the work that you've been doing at Canonical in confidential AI in general?
Absolutely. So we do have content that we do put regularly on our web pages. I invite you here to scan the QR code, which will take you to our confidential AI web page. We have a lot of launches with partners that I'm sure you'll be excited about hearing about. So yeah, do stay in touch with us through the web page. And for any questions that you will have, do use the contact form to contact our subject matter experts.
And I think to wrap it up, when it comes to RAG as well as any other GenAI use case, it's a journey. You identify the use case and you iterate as you go by doing data deep dives, experimenting, deploying models, scaling and optimizing. However, along the entire journey, you should keep security in mind and design both your workflow as well as your infrastructure with security in mind. Whether we talk about user management, confidential computing, security patching of the infrastructure, don't oversize security because otherwise it will be very difficult both to scale as well to move your projects to production. Thank you, everyone. And it's been great to have you, Michelle and Ujlal, in this webinar.
Thank you so much, Andrea and Ijlal.
Absolutely. And thank you everybody for who's been with us in this webinar. Thank you for the time you've taken to join us.